لا انا عايز اقل مده، مش
Good evening. Thank you for joining. We'll start in 2, 3 minutes. However, if anyone has any question or any concern, just let me know.
Doctor, I have a question.
Yes, Yafa.
But it's like it's not related to the content يعني. هو for assignment 3 لما like the grades were posted, I found like I lost like 40 marks ماشي. I
Okay.
emailed Shihab to ask him about like my mistakes so to like learn from them وكده. قال لي إن I got everything right but I lost the marks just for the steps. فهو ده عادي. قال لي إن all my
Well,
answers are correct.
I had the same problem with some other students. I will discuss with Shihab and let you know. Yeah.
Okay, thank you.
Uh,
ده for what يا دكتور؟
for assignment 3.
okay.
Uh, uh, Farha, for people that they don't have steps in the assignment, is it possible? Is it possible that that you provide the steps? Do you have a version that you have the steps in? يعني أكيد you had some steps يعني somewhere.
ما هو I wrote like steps مختصرة في ال Word document بس like the actual steps كان اللي هو شخبطة on like a paper بإيدي like a pen.
Okay,
That's
I'll
why I
come
just
back.
like wrote to
Just
the
one
an
second.
organized answer.
I'll come back. Just 1 second. Yes, yeah, Farah, sorry. Farah, you're still with me?
Yes, I'm here.
Yeah. So I'll check with Shihab if there is a way to resubmit the assignments with the steps for everyone to make sure يعني يعني as repeating يعني the assignment with the steps so that people who lost so many marks يعني for the trivial assignment they don't do يعني. So I'll check with Shihab and I will let you know يعني. Okay?
Okay, thank you.
Yes, Manar.
I had a similar case and I emailed Shahab and I told him if I can send him the steps because I had them written down in a paper but they were handwritten, and he told me okay, and I have sent them to him. So I think the rest could do the same. He accepted them.
So if for assignment say okay خلاص يعني it's the
Yes.
same case يعني. So for
Yes.
everyone that has the steps and he lost because of the steps, send to Shihab and I let him know.
Doctor, what steps were we supposed to send? Weren't we supposed to send just the code will output?
No. We're talking about assignment 3, the numbering system. Ahmed, yeah.
Okay.
We don't talk about anything else. Yeah. Okay. Any further question?
Doctor, how is the assignment?
Yes, يا محمد. Hello? Muhammad? Do you hear me يا جماعة?
Yes, doctor.
Yeah, we can hear you.
Yeah, so we don't hear Muhammad, but you hear me. Okay. Okay, Muhammad, you can send a chat if you want. Abdurrahman Mitwali, yes, the midterm on the 8th. It's a typo, yeah. Okay. So any further questions يا جماعة؟ طيب. Let me start. Let me start. Just to tell you for this section 4, this is the last lecture in the syllabus. And for section 5, inshallah, tomorrow I will be explaining the queues and possibly part of the recursion. So for section 4 today, is supposedly the end of the syllabus. So كل semester وانتم طيبين. And then we will start for this section and for the other section review sessions on Wednesday, inshallah, for both sections, even if I didn't finish if I didn't finish the syllabus tomorrow for chapter 5, still I will do the review session on Wednesday, inshallah, for both section 4 and section 5, inshallah. Yeah. So you will have roughly 2 weeks of intensive review for the course content. So hopefully this will pay off. Hopefully this will pay off for you in the project and the final and anything else. Yeah. Okay. Okay. Let me begin. Let me begin the lecture. So, who played? Who was enthusiastic about the puzzles when he was 10 years, 9 years? Who was interested in doing puzzles? Yeah, it's related. Yeah, I'm not telling so much stories here, so it's related to what we are discussing here. Uh, so Yusuf Omar, it
Yes,
seems
doctor.
that you're the only one who's interested in puzzles. Anyway, anyways, so when you were doing the puzzle, يعني when you have like 1,000 piece or 2,000 pieces and stuff like this, what was your strategy in building a puzzle? يعني يعني you have a puzzle and
Yeah.
and all of it are pieces. So what was your strategy to figure out or to build a puzzle? Yeah.
Oh, I just follow the patterns. So first of all, I do the corners, yani. That's the easiest. So then I would
Exactly.
follow the pattern of like
So you do the corners because the corners are obvious, yes?
yeah,
So you start by doing the corners and then you start from outside till inside, or you do something else, yeah.
yeah, correct. Take one
Yeah.
corner and start expanding.
So, and start expanding. And why do we start with the corner?
Because it's the easiest and it's
It's the easiest and the
basically
most obvious.
yeah,
And it is something solvable, yes?
yeah, doctor.
Yeah. So this is much related to what we are discussing, and this is much related to recursion. Recursion is based on recursion is based on the fact recursion is based on the fact that you decompose the big problem into smaller problems till you have an obvious or basic solution. Don't consider that I'm telling philosophies. يعني this is much related to C++ and recursion. You will discover this. So recursion means, even in real life, that you decompose the big problem into smaller problems, smaller problems, smaller problems, smaller problems, till you find out that you have an obvious or a basic solution, and then you start solving the bigger problems step by step, step by step, step by step, and step by step. Okay, so let's go a little bit deeper, and I need another volunteer, but has nothing to do with puzzles and has nothing to do with C++ as well. So I need some volunteer. So Abdurrahman Mitwali.
Yes, doctor.
Yes, Abdurrahman Mitwali. If you see this picture, can you just for a while forget about this part? If you see this picture with lots of people and assuming that they are holding each other hand, Can you figure out from seeing them? Can you figure out from seeing them how many people are shaking their hands together؟ يعني كم واحد ماسك ايده يعني؟ Okay. لو انت بصيت على الصورة دي تقدر تعرف كم واحد ماسك ايد التاني؟
كل واحد ماسك ايد واحدة المفروض.
ماشي كويس زي الفل. يبقى هتفضل تحسب
هما كام واحد؟
تحسب شوية. نعم.
انا قصدي ان هنحسب هما كام واحد، بعد كده نعمل الرقم ماينس واحد عشان في واحد مش هيمسك ايده، يعني هيمسك ايد بس اللي قصاده، فايده مش هتكون محسوبة.
ممتاز. ده كلام كويس جدا. ده كلام كويس جدا. يبقى اللي انت بتقوله ده if you have a function called h of n equal h of n minus 1 plus n minus 1 assuming that n equal 5 يا يوسف not يوسف يا عبد الرحمن assuming that n equal 5 can you solve this equation؟
هتبقى h of 4 plus 5. لا قصدي
Let's see
4
together.
plus 4 sorry.
h of 5 equal h
h of 4
ممتاز h of 4 plus n minus 1 plus 4 h of 4 plus 4. Do we know h of 4? Let's do it together. h of 4 is equal to what يا يوسف؟ Can we solve h of 4? h of 4 equal h of 3 plus 3. Do we know h of 3?
is equal to h of 2 plus 2.
Exactly. You're great, yeah, Yusuf. You're great. Okay, so h of 3 equal h of 3 equal h of 2 plus 2. Do we know h of 2?
Yes. It's h of 1 plus 1.
h of 1 هو في واحد بيسلم على نفسه؟
لا هتبقى 1 بقى على طول.
يبقى h of 1 is equal to كام؟
0.
0. مفيش حد بيسلم على نفسه يعني. إلا لو كان مجنون يعني، بس يعني محدش بيسلم على نفسه يعني. So h of 1 is really equal to 0. So h of 2 is equal to what يا يوسف؟
1.
To 1. Then h of 3 is equal to
3.
exactly. هايل. Then
h of 4 equal to 6.
Exactly. Then this
equal
one
to 10.
great. So you get a bonus, and you will get another bonus by answering me. What did we do?
Thank you, doctor.
Is it related to the puzzle? How this is related to the puzzle?
You solved it.
We have to go to the puzzle guy. Who is the Yusuf Omar. Yusuf Omar, you were the puzzle guy, yes?
Yes, doctor.
Yes. What did we do? How this is related to a puzzle?
Oh, we kept chaining down until we got like basically the corner where you can't go further, and then
Where we got the basic solution.
Yeah, and then we started going up.
Exactly. So this is recursion. then the lecture is almost ending. So basically, recursion means that we decompose the problem into smaller problems. We decompose the problems into smaller problems. Okay?
Yeah.
And till we find a basic solution. And this basic solution is obvious, is known. And then we will start going up to solve the bigger solution and the bigger solution and the bigger solution, etc., etc. Okay, so assuming that I want to write this in C++. So I need a volunteer, and I'll pick Khalid Hamza. Okay, Khalid?
Okay, Dr. I'm with you.
No, I'll pick Ala. I'll get back to you. I'll pick Ala. Okay?
Okay, Doctor.
Yes, doctor.
Assuming that I want to write this in C++,
Yes.
what do you think I should do? I need to write a function, and this function returns what, yeah, Ala? What data type does it return?
Integer.
Integer. Great. Let me call it compute shakes. Then what is an input to this function?
The number.
What do you think? We give it what? We give it n. So what's the input?
The number of people.
The number of people. So int number of people. Great. Then what is the basic case?
The H2.
No, the basic case is H1, because H1 is 0. Nobody shakes his hand, yeah. So if n equal 1, so what this function should return?
0.
Return 0. Otherwise, what is the general case, Ala? Look at this one. Look at this. Hn equal Hn minus 1 plus n minus 1. So assuming that I want to write it in C++, so how to transfer it to C++?
We can use this exact equation.
Yes, but what's h here? H is equivalent to what?
Maybe an array. No problem.
Oh, yeah.
Maybe you can create like an
H
array.
of n is what?
Maybe you can create an array and fill it, like using a loop.
No. Think differently. H of n in calculus, what is it? In mathematics, is
a function.
A function. And what is the name of the functions here?
H.
No. What's the name of the function here in C++?
Compute.
What's the name of our function?
Yeah, compute shakes.
Then return. Yalla. Compute shakes. of what?
Of the number of people.
Yeah. Look at the similarity. Compute shakes of what?
Of number
What is the input to compute shakes?
number of
Yeah,
people.
number of people,
What?
yes. Number of people. Number. So here, I'm sorry, if number of people. So compute shake number of people. Number of people only or
-1.
or exactly plus what?
Number of people minus n -1.
Exactly. Great. So what did we do? This is the first time in this semester that we call the function from inside the function itself. So compute shake, this is called recursion. So compute shake will, so from the function that is called compute shake, I compute the shakes again, however with n-1 plus n-1. So I will decompose. Of course, I will explain several examples. This is not the end of the lecture. So I will decompose the function into smaller problems, till I reach the basic case, which is number of people equal to 1, which is number of people equal to 1. So this is called recursion. Of course, I may not use recursion, and I can use conventional way of looping. I can use loops. Let me remind you with the equation in one of the exams, in the midterm exam, sorry. In the midterm exam, you were requested to write a function to compute factorial. And you were writing so many loops and stuff like this. And at the end of the day, you computed factorial. Okay? If we want to compute factorial of 5, let's think together. Forget about anything and everything. Let's go to Khalid Hamza again. Thank you, Ala. You get 2 bonuses. Okay?
Thank you, doctor.
Okay. Let's go to Khalid Hamza again.
Zero,
Khalid? Okay. Let's play together. Not puzzles. We left the puzzles for Yusuf Ahmed. Okay. So, if we want to compute factorial of 5, this is what? This is 5 times what?
times 4 times 3 times 2 times 1.
if I tell you that factorial of 1, what's factorial of 1 يا خالد?
1 يا دكتور.
1. Okay. If I know factorial of 1, can I know factorial of 2?
Yes,
How?
because factorial of 2 is equal to 1 times 2. 1 times factorial of 2 times factorial of 1, I mean.
2 times factorial of 1.
Yes.
Exactly. Why? Because this is factorial of 1, which is 1. So, great يا خالد. So, let's go up. The same methodology, factorial of 5, similar to factorial of 1. So, it is factorial of 4 times what?
Factorial of 4 times 5.
Exactly. And what is factorial of 5? Factorial of 4.
It's factorial of 3 times 4.
Factorial of 3 times 4. And what is factorial of 3?
F of 2.
Yes. 3. Great. And what is factorial of 2?
2 times factorial of 1.
2 times factorial of 1. Do we know factorial of 1?
Yes, doctor, it's 1.
Yeah. Then factorial of 2 is 2 times 1. Factorial of 3 is 2 times 3, which is 6. Factorial of 4 equal 24. Factorial of 5 equal 24 times 5, which is 120. This is a recursion. This is basically a recursion. Assuming, Khalid, that we want to express this in C++. Assuming, what should we do?
We're gonna define the variable, the x, for example. Which
So
is
we
gonna
have the function. The function, we will call it compute factorial.
Okay.
Compute factorial. What does it receive?
A number, x, for example. And
A number.
Yeah.
So, if n equal 1, what should we return?
1.
Great. Else?
Doctor, it should be equal, right?
Yeah, sure.
Equity. Yeah. Okay.
Else, return. What should we return?
I think, doctor, we're gonna make it n times.
Great. What is the name of the function? Compute factorial. And we'll give it as an input a smaller problem. So, what's 1? It's assuming that this is n. This is what?
N minus 1.
Exactly. Assuming that this is n. This is what?
N minus 1.
Great. Assuming that this is n. وهكذا. Then it is n minus 1. Okay.
Oh, okay, doctor.
Okay.
And it will keep,
yeah.
looping, doctor.
So let's trace it together. Assuming that I am in the main, okay, and then, I am in the main, and then this is the main function. I am in the main, and then assuming that I defined a variable called my_n, then my_n, assuming that I will get it from the user, my_n, then int result. Okay, continue with me يا خالد. Result equal compute factorial of 5. What will happen in the function? I will tell you what it will happen. Okay, so this compute factorial of 5 will call this function that we just make. So we will enter the function that is called compute factorial. Is n equal to 1 يا خالد? N
is
is
not.
equal to 5, right?
Yes.
Yes. So else, so are we in the if statement or in the else?
And the else. Doctor.
In the else. So n, so compute factorial of 5 is equal to compute factorial of what? Compute factorial of n minus 1, which is
4.
how much يا خالد? 4, exactly. Times n, which is time 5. Great. Then the computer or the compiler will it be able to compute factorial of 4, or it will call itself again?
Yes, it will keep calling itself, Doctor, until it's 1.
It will keep calling itself. Don't touch. So it will keep calling itself compute factorial of 4 equal compute يعني factorial of 3 times n, which is 4. Then compute factorial of 3 will equal to compute factorial of 2 times 3. Then compute factorial of 2 till we find what? We find the case where n equal 1. Then it will compute it from bottom to up. And this is related to something that we have just studied. What it is? So,
يا دكتور
excuse me,
stacks.
who said stacks?
Khalid.
Yeah. And Farah, you said stack?
Yes.
Yes. So Farah and Khalid will get double bonus.
Thank you, Doctor.
Thank you, Doctor.
Okay. So Khalid, you have 4 bonuses this lecture. You're very fortunate, yeah. So you should محتاج توزع البونسز شوية. Anyway, so what happened inside the computer, inside the compiler, if the compiler didn't manage to to evaluate a function, so it will call itself till it reach a basic case, which is n equal to 1. And then it will pop from the stack memory. You remember that there's a stack memory and there's a heap memory. So which is larger, the heap or the stack?
heap يا دكتور.
The heap. Exactly. The stack memory, this is a vision. This is a smaller memory. 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 And this is basically, this is a smaller memory. And just 1 second. This is a smaller memory, and the stack memory is very similar to the stack. It evaluates last in, it's LIFO, last in first out, last in first out، يعني اللي بيخش في الآخر بيطلع الأول. طيب يا جماعة is there anyone that doesn't understand the concept? Let me repeat if you don't understand. We will have several examples here other than the factorial, but does everyone understand what I'm saying?
Yes, doctor.
Wait, doctor, you said it has the same, like it's like the LIFO?
It's like the LIFO. Why, Miriam, it's like the LIFO? Because we evaluate the big thing, then we reach to the base case. The base case is the one that is solvable. The base case is the one that is solvable. Yes? And then we evaluate the solvable case. In this case, it's n equal 1. And then we go up. So, you're with me, Miriam?
Yes, doctor.
Yes. So, in the factorial, the solvable case, n was equal to 1, to what?
I can't really hear you, doctor.
What I am saying that in this example of factorial, the basic case or the solvable case is n equal what?
1.
1.
Mhm.
So I evaluated n equal 1 till n equal 5, for example.
Mhm.
So n equal 5, this is the complex case. I cannot evaluate except by having smaller problems and smaller problems and smaller problems. Then if I solve the basic problem, then I go up. خلاص? So that's why it's like a stack. That's why it's like a stack. We will have other examples, but is it okay so far, Miriam?
Yes, thank you, doctor.
Okay. Okay, so now we understand the basic concept. In some problem, it may be natural to define the problem in terms of the problem itself. What does it mean? What does it mean? It means Farah is asking, Doctor, how will the main know that it should start with the basic problem? No. The main will call the function, and the function will start looping itself without a loop. It will start calling itself again and again and again till we reach the basic operation. So the main will say compute the factorial of 6. Then it will call the function, compute factorial of 6. Then I will go inside the function. So factorial of 6 equal factorial of 5 times 6. وهكذا till I reach the basic operation. I will explain it again.
دكتور
Yes.
معلش عندي سؤال. هو هي الفانكشن بتريبيت نفسها من غير ما احطها في لوب؟
من غير ما تحطها في لوب. ده this is recursion. يعني I will explain that diagrammatically. يعني. So just give me one minute. So in the recursive solution, the solution to the base case is provided, and the solution to the bigger problem is expressed in terms of smaller problem. Okay? So this is what we have just said, that computer used a stack structure to keep track of recursion. When execution of the function definition reaches a recursive call, execution stops. Okay? And then the function calls itself again. And then the function calls itself again. طيب, what if I don't have a base case? Can someone tells me if I don't have a base case? So let's see something like this. Assuming this is a factorial function, it is a factorial function. Assuming that I don't have this base case, can anyone tell me what's going to happen?
function هتفضل تعيد نفسها كتير endless.
It's like an
great. What were فرح كنت هتقولي ايه؟
I'm saying it's like an infinite loop. يعني.
It's like an infinite loop. Why? Because the function will call itself forever. The function will call itself forever. طيب, both فرح and Freddy, this is a Christmas day, so both of you will get a double bonus. Okay?
شكرا دكتور.
So فرح also هتوزع bonuses دلوقتي. So the function will call itself again and again and again and again. So what will happen to the memory? What will happen to the stack? Stack is small memory.
To terminate.
لا
هيحصل ايه؟
stack overflow.
هيحصل stack overflow. يعني ايه؟
terminate
كده يعني ايه؟
يعني الميموري هتتملي يا دكتور، فبعد كده اي داتا جديده او اي حاجه
مش هتعمل لها سيف
في البروجرام، مش هتتعمل لها سيف في الداتا، او هتبقى تحول الى
كل اللي بتقولوه صح. give yourself a double bonus. What will happen actually انه الميموري هتفرقع بالبلدي كده.
ماشي.
Just 1 second.
Thank you يا دكتور.
Take your time دكتور.
1 second please. Okay, I'm back. Sorry. Don't worry يا جماعة. I'm not having a corona. I'm a normal person. I'm بكح بس.
سلامتك يا
So,
دكتور.
الله يخليك. شكرا. So, can anyone tells me how? Let's have some mathematics here. When I want to evaluate n to the power of 3 مثلا يلا think recursively. How is it evaluated? يلا someone.
We need to multiply 2 3 times.
Yeah. So we multiply 2. Let it be just for easy. 2 to the power of 4. So we need to multiply 2 times 4 times. Type. Who's with me? Who was?
آلاء يا دكتور.
Ala. So we'll continue the Christmas for Ala. So, okay. 2 times 4. So if I tell you 2 to the power of 3.
2 times 2 times 2.
Times 2 times 2. If I tell you 2 to the power of 2.
2 times 2.
2 times 2. If I tell you 2 to the power of 1.
2.
2. If I tell you 2 to the power of 0.
1.
1. How can I express this recursively? See what did I do? See the 2's كده.
Yes, they decrease by 1 every time.
They decrease by 1 every time. That's great. So, assuming that I have a power function equal power of n. So, it is equal power of what?
If it's power of n, it's
equal power. I want to express the function in terms of itself.
yes. So it's the power of.
Look at the pattern يا جماعة. Look at the pattern.
n minus 1.
Exactly. n minus 1. n to the power of 4 equal n to the power of 3 times 2.
ونفضل نلوب لحد ما ال n تبقى equal 0 وتبقى return 1.
Or if n equal 1, so it is exactly equal to what? Yeah?
To 2. أو to the number.
Which is the number? Which is n. So that's recursive. That's recursive. Exactly, Farah. That's perfect. So this is the power. So start to think recursively. How do I do it using loops? I can do it using very simple loop. But recursion is slower. Recursion is slower. Why is it slower? Because it calls the function itself again and put it into the stack and stuff like this. So recursion is recursion is repeating itself. Recursion is slower. Recursion is slower. However, it's more intuitive. It's more intuitive. It's more intuitive. Yeah. We will write it, ya Mariam, in terms of C++, but first I want to write it mathematically. So for factorial, we started by the factorial. This is the C++ code. This is the C++ code. So how does it work? Int f, int n, if n less than or equal to 1, so I return 1. يعني factorial of 1 or 0 is 1. Factorial of 1 or 0 is 1. Otherwise, else return n times fn minus 1. What this is equivalent to? Assuming that I want to write factorial of 5. So factorial of 5 equal 5 times factorial of 4. Type. The function will call itself. So this is the first call. Then factorial of 4 equal return 4 times factorial of 3. This is the second call. And then return 3 times factorial of 2. This is the third call. Then factorial of 2 equal which is return 2 times factorial of 1. Then factorial of 1 equal means return 1 times factorial of 0. Factorial of 0 is known, so we reach into the base case, and this is exactly the base case. And after reaching the base case, we go up. This is called a stack. We pop this element, we pop that element. This element is the last one that inserted in the stack. We pop it, we pop this one and compute 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 it. So return 1 times factorial of 0, which is 1. Returns 2 times factorial of 1, which is 2. Return 3 times factorial of 2, which is 6. Return 4 times factorial of 3, which is 24. Return 5 times factorial of 4, which is 120. That's it. So this is basically the C++ code, and this is how it works. Okay. So, yes, Yusuf, yes.
دكتور معلش عندي سؤال. هو ليه احنا بنحطها اف وال سي مثلا، ما بنحطهاش مثلا في اري، مثلا نقول اري اي مثلا ونكتب مثلا اي ايكوال 1 ونعملها من
بص
رقم
يا يوسف، بص انت عندك طريقتين، خلاص؟ يا تعملها بالطريقة الطبيعية اللي هي لوب وتفضل تعمل اللي هي لوب زي ما انت عملتها في الامتحان.
تمام.
خلاص؟ assuming انك عملتها صح، انا مش فاكر يعني، بس شكلك عملتها صح يعني، بيتهيألي يعني.
ايوه يا
يعني انت عملت ايه اللي انت عملته في الامتحان؟ فور لوب. خلاص؟
بالظبط.
عملتها بفور لوب. بديل الفور لوب دي الطريقة التقليدية، تعملها بريكيرجن. ريكيرجن أقصر وبيماثل الطريقة اللي المخ البشري بيفكر فيها. يعني انت الطريقة اللي هي more intuitive انك تعملها بريكيرجن. خلاص؟ في حاجات لو انت ان شاء الله في 110 لو ربنا أراد وعشنا واديتكم 110 كده
ان شاء الله.
ان شاء الله، بس انت هتبقى معايا يا يوسف.
ده كده كده يا دكتور، والله انا بحاول.
ايه؟
والله بحاول، لسه الادفايزنج بتاعي مش دلوقتي.
نعم؟
بقول انا والله بحاول ان شاء الله اخد 110 مع حضرتك، بس انا لسه الادفايزنج سيشن بتاعتي مش دلوقتي.
ماشي، ما انا عارف، انا ان شاء الله يعني انا مستنيك في 110 يعني.
ماشي يا دكتور اشرح.
اوكي. ففي 110 في كيسز لو كتبتها بالفور لوب، وبالوايل لوب وبالطريقه التقليديه هتكتب pages of code. لو عملتها ريكيرجن هيبقوا 3-4 سطور. تمام
يا دكتور.
يعني
أوكي.
يمكن هي مش باينه في الفاكتوريال، تمام، ولا
تمام.
باينه في الباور، عشان دي حاجات دي فانكشن سهله خلاص. لكن لو انت عملت حاجه في التوبكس بتاعت 110 هتبقى حاجه معقده جدا لو انت كتبتها بالطريقه التقليديه، عشان كده بتلجأ لريكيرجن. لكن احنا في 106 عندنا بس البيزك كونسبت اوف ريكيرجن، لكن ان شاء الله في 110 لو انت حاولت اساسا تكتبها بالفور والوايل لوب وبالاريز والبوينترز والكلام ده كله، هتلاقي نفسك دخلت في متاهه كبيره، فبالتالي بتضطر تكتبها بريكيرجن.
اوكي ثانك يو يا دكتور.
So the beauty of recursion مش هيبان في الكورس ده، البيوتي اوف recursion هيبان ان شاء الله في ال 110 ان شاء الله. اوكي طيب be with me يا يوسف. اوكي
حاضر يا دكتور، انا حضرتك.
So forget about this part, don't look at it. Okay طيب this is called Fibonacci series. خلاص.
Okay.
What does it say? It says that
1
Fibonacci of 0 is equal to 1 and Fibonacci of 1 is equal to 1. طيب التو اللي هنا equal لإيه وإيه؟
1 plus 1 اللي قبليها.
كويس. ال 3 اللي هنا
2 plus 1.
equal to what?
2 plus 1.
Exactly. يبقى اللي قبليها واللي قبل اللي قبليها. ال 5 is equal to what?
3 plus 2.
Okay. ال 8 is equal to what?
5 plus 3.
ال 13 is equal to what?
8 plus 5.
طيب. If I tell you to express it in a more general way. So Fibonacci, this is the name of the function of n equal to what يا يوسف? Without looking at the red part. Equal Fibonacci of what?
n minus 1 plus Fibonacci n minus 2.
أول مرة تاخد دبل بونص يا يوسف. Equal Fibonacci of n minus 2. So that's it. So to express it in C++, it's extremely easy. This is the name of the function, Fibonacci. It receives an input. If n less than or equal to 1, return 1. Otherwise, return Fibonacci n minus 2 plus Fibonacci n minus 1. So easy. So easy. The difficulty is not the C++ code. The difficulty is to figure out how the general case will look like. فعشان تعرف الجنرال كيس دي عاملة ازاي لازم تقعد تدرسها كده في دماغك كده خلاص لغاية ما تعرف الجنرال باترن. يعني تعمل جدول كده زي الجدول ده وتبتدي انك انت تشوف الدنيا عاملة ازاي. جدول تعرف البيز كيس عبارة عن ايه وتبتدي بالارقام تحاول تستنتج الجنرال كيس عاملة ازاي. Writing in C++ is nothing. طيب let's say it into a tree. Fibonacci of 5 is Fibonacci of 4 plus Fibonacci of 3. Fibonacci of 4 equal Fibonacci of 3 plus Fibonacci of 2. Fibonacci of 3 equal Fibonacci of 2 plus Fibonacci of 1. Fibonacci of 3 equal Fibonacci of 2 plus Fibonacci of 1. Fibonacci 1 and 0 خلاص. I know what's Fibonacci of 2 and I know all of this. Then I can evaluate Fibonacci of 3, Fibonacci of 2, Fibonacci of 2 and Fibonacci in 1. Then I can evaluate Fibonacci of 4 and Fibonacci of 3 and subsequently Fibonacci of 5. And then I will leave this example deliberately. I will leave this example deliberately. I will not explain it as an example that you can see it at home and try to figure out the general case and the basic case. So that's it from my side. Thank you very much for joining, and كل semester وانتم طيبين in terms of content. However, we will see each other inshallah for many review sessions, inshallah, more than 4 or 5, inshallah, with this section and the other section. Thank you very much, and see you Wednesday, inshallah, and we might make a review session on Tuesday. Still, I didn't, I am not decided, but we'll let you know. So thank you very much for this, and see you Wednesday, inshallah.
Thank you, doctor.
Thank you.
Thank you يا دكتور.
Thank you doctor.
باي.
شكرا دكتور.
دكتور دكتور ممكن أسأل سؤال؟
دكتور
مين اللي كان عايز يسأل سؤال؟
أنا
اوكي يا زينة، اوكي.
كنت عايزة أسأل لو ميعاد midterm 2 اتحدد.
احنا قلنا 8/12.
لا أنا قصدي كالساعة.
لا، الساعة ما اتحددتش، بس أغلب الناس قالوا لي إن هما مش هيبقوا available لغاية 3:30 4. فإتس likely يعني إن هو يبقى بعد 4 إن شاء الله يعني.
أوكي شكرا.
يعني أكيد هنعمله في ساعة كلكم متفقين عليها يعني.
أوكي شكرا.
أوكي زين. يس عبد الرحمن.
I got disconnected في حتة في بيانكي فما فهمتهاش أوي.
الفيبوناتشي؟
الفيبوناتشي.
أوكي. I'll explain it again.
دكتور معلش، هي كلاسز في شابتر كام؟ عشان بحاول ادور على السلايدز بتاعتها مش لاقيها.
الكلاسز في chapter I think 9. just wait ثانية واحدة.
الناين كان الدايناميك arrays تقريبا.
It's just 10 I think. just let me see. 10 يا رنا.
اوكي thanks يا دكتور.
اوكي نرجع لعبد الرحمن. just 1 second يا عبد الرحمن، انت معايا؟ طيب البيز كيس يا عبد الرحمن انه فيبوناتشي اوف 0 بيساوي 1. خلاص، فيبوناتشي دي معادلة خلاص، وفيبوناتشي اوف 1 ايكوال 1. طيب الاثنين بتساوي ايه؟ بتساوي 1 بلس 1. الثلاثة بتساوي ايه؟
2 بلس 1.
exactly. الخمسة
3 بلس 2.
exactly. فالجنرال كيس يا عبد الرحمن انه الفيبوناتشي بتاع رقم بيساوي الرقم اللي قبليه زائد الرقم اللي قبل اللي قبليه. دي الجنرال كيس. فيبوناتشي اوف n equal فيبوناتشي اوف n minus 1 plus فيبوناتشي اوف n minus 2.
اوكي.
محتاجة بس شوية تمرين يعني، مش بتيجي من أول مرة يعني.
لا فهمتها بجد.
لا أنا عارف، أنا بقول لك بصفة عامة يعني.
اوكي.
محمد انت كنت عندك سؤال يا محمد.
ثانك يو دكتور.
دكتور، هو انا بس في حاجه مش فاهمها هنا في الريكursion. لازم تكون انت، يعني لازم تكون فانكشن ريتيرن حاجه،
لا يا
ولا
حبيبي، لا
void
لا
ما ينفعش؟
لا، هي بالصدفة. لا، هي لازم ترن حاجة.
يعني لو void مثلا، بس void
لا لا،
بترن
ما
حاجه جواها،
تنفعش
يعني
ما تنفعش.
ما تنفعش، لازم
ليه؟
تريتيرن حاجه.
عشان لازم لما تعمل ريتيرن اسم الفانكشن بتروح منادية على الفانكشن يا محمد.
فتطلع فاليو تقوم عاملاه بلس او ملتبلاي او على حسب انا عامل ايه.
بالظبط.
تمام. طب
فما
حاجه تانية دكتور،
تنفعش
معلش.
مع الفويد.
انا دي حاجه سالتك فيها في اول ليكتشر، واول ما سالت حضرتك الموبايل فصل فما سمعتش الاجابه. هو assignment 3 بتاع numbering system كان out of 20 ولا 120؟
بص انا مش عارف الحقيقة، بس
اصل انا عندي نازل لي 25 من 20، يعني كان out of 20، فانا مش فاهم.
مش عارف.
اصل هم لقيتهم بيقولوا ان lost 40 marks، هو الاسايمنت فيه كام 40 ماركس اصلا؟
ما انا مش عارف، فانا هخلي شهاب يوضح النقطة دي.
هو انا اصلا سيكشن 5 حضرتك عارف.
لا طيب هخلي مريم توضح النقطة دي.
تمام، اوكي.
حد عنده
شكرا يا
سؤال
دكتور.
آخر يا جماعة؟
شكرا يا دكتور.
فرح محمد، انت لسه هترجعي الطب ولا ابتدينا نعجبك شوية؟
لا خلاص.
نعم؟
لا خلاص.
مش سامع.
هكمل إن شاء الله.
هتكملي إن شاء الله؟ طيب ماشي.
أنا بس كنت عايزة أسأل حضرتك
أنا معلش مش سامعك يا فرح.
بقول عايزة أسأل حضرتك حاجة في الديناميك 2D array، كده الصوت أوضح؟
كده الصوت أوضح.
طيب هو أنا ممكن أشير سكرين؟
شو بس تديني دقيقة وأرجع لك.
شور.
Yes يا فرح, you can share the screen.
cannot start.
ثواني, I stopped shared.